Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a numerical, that is problem number 5, which is based on when, or you can say inverse Z transform signals when numerator degree is greater than denominator. We'll see a problem number 5 first. Now, the question is find inverse Z transform of following signal, and signal is given x of z is 1 plus 2 z inverse plus z raised to minus 2, and in denominator we have 1 minus 0.75 z inverse plus 0.125 z to the power minus 2. Look at here. Here the numerator degree and denominator degree is same, which means we have to perform division only once. So, as the numerator degree and denominator degree is same, we'll divide numerator only by 1, so that in remainder degree of resultant or the remainder will be lesser than denominator or divisor. Now, here first of all, what is important, we are going to divide the first element, and the first denominator element is also 1, numerator element is also 1. So simply if I multiply 1 by 1, the answer is always 1, that we know. Now simply multiply 1 with this whole divisor. Now to cancel this both the one, what is important, we need to change the value of next terms, or you can say the divisor terms. Then we can cancel this whole part. Now as the sign is changes to plus, so 2 plus 0.75 is always 2.75 z inverse, and here the sign is changed to minus. So what you can say, 1 minus 0.125. Answer is always 0.875 z to the power minus 2. And now look at here, the first element degree is z to the power 0, and in remainder the first element degree is z to the power minus 1, which means here the degree is lesser than 1. In remainder degree is lesser than 1 compared to denominator, so we can stop here. That's why I'm telling you, if the degrees are same in numerator as well as denominator, then we are going to divide only one numerator, or you can say we are going to divide numerator only once by denominator, so that automatically the degree of remainder which will be lesser than denominator. So this is nothing but our quotient, remainder and divisor. And we know that how to write this value, that is like q plus r by d. So I'm going to place all the values in this formula. My quotient value is 1, my remainder value is over here, and at the end the divisor value. Now this is our x of z, but basically we cannot apply directly inverse z transform on x of z because we cannot solve this part directly. We have to take help of a partial fraction. So let's say this whole part is nothing but my x1 of z, and let's mark this equation as a 1. This one is my x of z. Basically, look at here, the last question. In the last question we have solved this numerator as it is by keeping z inverse as a z inverse, but now we can convert this whole function into normal z also. How? I'll show you. Look at the lowest degree which is present in denominator, and it is z to the power minus 2. So simply multiply numerator and denominator by z to the power plus 2, so that this lowest degree can be converted into a positive degree. So what we will get, if I multiply z square in numerator, then what we can say, that our answer. In our answer, z to the power minus 1, that will be multiplied with z to the power plus 2. Bases are same, then powers always get added. This minus 1 is added with plus 2, so of course you will get z to the power plus 1 only. And now z to the power minus 2, and that will be multiplied with z to the power plus 2. Bases are same, then minus 2 and plus 2 gets added, and we'll get z to the power 0, and that will be nothing but 1. Now the next one, what we have here, the answer is 1 minus 0.75 z inverse plus 0.125 z to the power minus 2. And if I multiply this whole with z, then what you will get? Basically, in this function, when our question is in normal z, then 1z should be present in the left hand side denominator, or you can say in the denominator of left hand side, and for that we'll multiply numerator by z only. Or you can say divide both the sides by z, so that automatically 1z will be there on left hand side denominator. But first of all, we will factorize whole denominator. And what are the factors? The first one is half and another one is 1 by 4. So we can write z minus half and z minus 1 by 4. So here we have 3 poles, then of course we will use 3 different variables, that is a by z, and this is nothing but my equation number 2. Now do one thing, simply multiply this denominator on the right hand side. What you will get? And this is going to be my equation number 3. Now I'm going to substitute values of z such that you will get the value of a, b, c respectively. Now substitute z value. Which term you are going to substitute for? I'll substitute z equals to 0 first in my equation number 3. Basically this is my equation number 3. If I substitute z equals to 0, then this term will get cancelled, or you can say product term will get cancelled. This whole b term gets vanished, this whole c term will get vanished. You will get the answer only for a. And that value is nothing but minus of half and minus of 1 by 4. Now simply minus into minus is plus, and half into 1 by 4, that is 2 into 4 is 8, so we will get 1 by 8. 1 by 8a. Now just simply multiply 8 on both the sides, so that this 8 will get cancelled, or else you can say that the shift this 8 on right hand side, so that will be multiplied with 0.8758. And after multiplying 8 with 0.875, what do you get? Answer is 7. And this is the value of a. Now similarly substitute z equals to half in this whole equation. So first of all, this z is replaced by half, so you can write 2.75 by 2 plus 0.875. Now as if I substitute half over here, then half minus half gets cancelled, and this will be replaced by 0, and 0 into whole a term becomes 0, so I can replace this whole term by 0. Next, this, look at here in c, here also we have a half, so half minus half becomes 0, and 0 into anything is answer is 0, so that this c term will also get vanished, and I'm going to represent or replace this whole term by 0. But first of all, I'll write this value of b. Now half minus 1 by 4 is always 1 by 4, and 1 by 4 into 1 by 2, answer is 1 by 8. So what you will get? 1 by 8 into b. And if we add a left hand side value, then what you will get? After adding this value, what I've got, that value is 9 by 4. And if I multiply both the sides by 8, or simply just if I shift this 8 on left hand side, then what we can get, say that this 8 will be multiplied with 9 by 4, and this 4 can divide this 8, and answer is 2, and 9 into 2 is 18. So my b value is 18. Now we will substitute z equals to 1 by 4. So all this z will be replaced by 1 by 4. So look at here, look at in A. Here we have z minus 1 by 4. So this 1 by 4 and 1 by 4 will get cancelled. Now I'm going to replace this whole A by 0. Similarly, here also we have in B z minus 1 by 4. If this z is replaced by 1 by 4, then again 1 by 4 will gives us a value 0. And 0 is multiplied with B, answer is 0. So I'm going to replace this A and B whole product term as a 0. Now in C, what you will get? 1 by 4 and 1 by 4 minus half. And look at here on left hand side, this z is replaced by 1 by 4, so I can write 2.75 by 4 and 0.875. After adding this left hand side, what I have got? 25 by 16, and 1 by 4 minus half, answer is minus 1 by 4, and 1 by 4 into 1 by 4, answer is 1 by 16, but minus 1 by 16, or you can say minus c by 16. And if I multiply both the sides by minus of 16, then 16 get cancelled. So my c value is minus 25. And now I'm going to substitute all these ABC value in equation number 3. So I have substituted this value in my equation number 2. Now if I multiply this z on right hand side, what you can say, this z will get cancelled, so we can write only 7 is there. Now what about next one? And this is my x1 of z value. I'll substitute this x1 of z value in my equation number 1. So 7 plus 8, we can write 8. And now we can apply inverse z transform on whole equation. If I apply inverse z transform both the side, then x of z can be represented by x of n. Then here we have only constant term, that is 8, and constant inverse z is, we know that, del of n. Next 18 I have taken common, so z upon z minus half is nothing but a raised to n u of n, and my a value is half. So we can write half raised to n into u of n. Minus 25 is constant. Here again z upon z minus 1 by 4, that is, this is the formula of z upon z minus a, and which is nothing but inverse z transform of a raised to n into u of n, and here my a is 1 by 4. So we can write 1 by 4 raised to n and into u of n. And now again, if you want, then you can take u of n common. And this is nothing but the inverse z transform of given x of z. If you want, then you can stop here also, or else here also. So that's all for now. Thank you for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.